Imagine a planet once very much like Earth, with rivers flowing, clouds in the sky, rains, perhaps even oceans. But today, it's a dead red desert. What happened to Mars? How did a planet that could have hosted life become a dry, cold wasteland? In this comprehensive episode, you'll discover, did Mars truly resemble Earth in its past? How did the planet lose its core, atmosphere, and magnetic field? What evidence of water did orbital probes uncover? Which countries sent missions and what did they find? Can Mars be terraformed and made livable again? What would humanity need to settle there? This is a story of a world's demise and the hope of its rebirth. Scientists today believe that nearly 4 billion years ago, Mars had a climate similar to Earth's. This theory is based on numerous surface images captured by orbiting spacecraft. Researchers found traces of ancient riverbeds, deltas, and possibly lakes. NASA's data confirms the existence of stable liquid water on Mars in the form of ancient river valleys. Formations like Valles Marineris and many other hydrological features suggest that water didn't just exist, it flowed sometimes for long periods. Moreover, the atmosphere was thicker then, and the climate warmer. Rain may even have fallen. These discoveries have changed our view of Mars. Instead of a dry desert, we now see a world that once might have been alive. The key to Mars's downfall lies in its core. A planet's magnetic field is generated by a molten metallic core. In its early days, Mars had such a field. But about 3 billion years ago, it vanished. One hypothesis is that a series of massive asteroid impacts disrupted heat flow within the planet's interior, causing the core to cool and cease its motion. With no magnetic field, Earth's natural shield against solar wind, Mars's atmosphere began to erode. Solar wind, the stream of charged particles emitted by the sun, continued stripping away atmospheric molecules over millions of years. Weak gravity also allowed light gases to escape more easily. The result was loss of atmospheric pressure, surface cooling, and the complete loss of habitability. The first solid proof came from the Mars Odyssey orbiter, which detected water ice beneath the Martian surface. Later, the Phoenix lander touched down in the planet's northern regions and scraped the soil, uncovering frozen water. Later still, the Mars Reconnaissance Orbiter identified minerals that only form in the presence of liquid water. The Curiosity rover, which still explores Gale Crater to this day, discovered chemical compounds typical of ancient freshwater lakes. Scientists also found certain salts on the surface that can temporarily retain moisture, even in Mars's current cold climate. The first spacecraft to reach Mars was a Soviet probe, Mars 1. But the real breakthrough came with NASA's Mariner 9, which became the first satellite to orbit Mars in the early 1970s. Follow-up missions included Viking 1 and Viking 2, NASA's first successful surface landings in the 70s. Europe's Mars Express delivered high-resolution imagery of the planet. Spirit and Opportunity, two rovers that far outlived their expected lifespan, traversed the Martian surface and conducted geological investigations. Curiosity continues its mission, studying soil, rocks, and long-buried organics. Perseverance and its companion drone, Ingenuity, are collecting samples to potentially send back to Earth. Other players in the Mars game include China, with the Tianwen-1 orbiter and Zhurong rover, and the UAE's Hope spacecraft, showing Mars truly became an international frontier. Can Mars be revived? Terraforming. In theory, it's possible. Terraforming means transforming a planet's climate to make it suitable for human life. Several ideas have emerged. Release greenhouse gases like carbon dioxide or synthetic gases to warm the planet. Vaporize polar ice caps using nuclear explosions or massive orbital mirrors. Introduce specially engineered microorganisms to produce oxygen. However, these processes would require tremendous resources. Thousands of rocket launches and centuries to achieve partial atmospheric restoration. And without a magnetic field, any new atmosphere would slowly be ripped away. Mars isn't just a dead planet, it's a mirror of our future. It presents a challenge and an opportunity. If humanity can breathe life into a red world, perhaps we can save our own. If you love mind-blowing science and facts, hit like, subscribe, and share your thoughts in the comments. Let's explore the world together.